Okay, grade nines. I know you're as excited as I am to be done with math for the year, 11.3. We finally see some probability, we see some actual math kind of coming into this data analysis unit with probability in society. So we'll jump into a few examples right away here. We'll do a little bit of review of the last couple sections here, identifying the population. But you're a town planner, you know that if people want walking trails or bike paths. So you're gonna ask people, there's 15,000 people in the town, you wanna survey 1,500, so about 10% of them. Identify the population. Well, the population is going to be people in the town. Okay, so that's all the people that are in that town are in the population. Describe how you might select the sample and how you would conduct the survey. I typically like stratified, where you might pick people from regions throughout the town, not just all people at one point on the street corner, but try to make sure, or maybe different age groups. So depending how you want to split it up, you can do it one of those ways. But typically try to get people from all areas: old people, young people, people from that live over here, live over here. Try to get a balanced idea of what people like. Okay, as a result of the survey, suppose 60% of people would prefer bike paths. What prediction would you make about the preference for the town's population? Well, if we assume that the sample is big enough, which 10% is a pretty good sized sample, and we assume that the sample is going to be reflective, if it's a fair sample, then 60% of this, we could say that, well, we would expect around 60%. So I could actually just multiply 6.6, I'd get about 9,000 people. We could actually calculate how many, 60% of 15,000, so 0.6 times 15,000. What assumptions did you make? Well, we're assuming that that sample is big enough, and we assume that the sample is going to be reflective of the population. Okay, so we're going to be tackling a few questions similar to that in some of these examples in this last section. Ruth wants to determine the most common eye color of students. All grade 12 students in 5 of 7 high schools in the city recorded their eye color. A total of 2,300 students were surveyed. The results are shown in the table. So we've got brown, blue, green, other. So from the results in A, predict how many of the 7,200 students at the local college will have brown eyes. Show your thinking. So we keep in mind, this is important, high schools versus college. Well, if I wanted to kind of take this sample out of the 2,300 students, if I want to predict how many would have brown eyes, just based on the stats, I would take 1656 out of 2,300. That'll give me kind of the decimal form of the percent, and then I would apply that, I would multiply that by the 7,200 students. So we can always take the percent and apply that. So 1656 divided by 2,300 gives you about 72%. So if 72% of the sample have brown eyes, we would have no reason to expect that it would be any different in the total population. Now, or would we? Do we have a reason? In the last example, if you're surveying people throughout the city and then you apply that to the whole city, does that make sense? In this case, does it make sense to take the eye color of high school students and apply it to college students? You might say yes. So is your prediction reasonable? You might say, yeah, this is a reasonable prediction. But there could be certain things at play. For example, if this is university, where I went, there is a significant portion of immigrants. So people from China coming to university that they wouldn't be in our high schools. And in this case, with eye color, a lot of Chinese people would have brown eyes. So it would change the results. You might have a higher percentage. So it's not being racist or anything, but it's just, you're going to get people from different areas, where in high school you might have a different type of population of people than college. So if you're willing to say, yeah, it's about the same types of people going to the high school as it is to the college, then fine, then you're good. Yeah. But if you have reason to believe that might be different, then you'd have to say so, and say that that's your assumption. You can still do the math, but say that you have an assumption to make. Okay, so use the information from example 1. So we could do the same idea here with blue eyes or green eyes. So for us, I have the calculations made. But blue eyes versus green eyes, there's 483. So we can just do it here. 483 out of 2,300 again. So we get the percentage of blue and apply that to our population. And we do the same with the green eyes. 115 out of 2,300 and apply that to our total population. And again, for the same reasons, you'd be able to say, is your prediction actually reasonable or not? My calculations say there should be about 1,512 and 360 on these. Okay, so that's taking the exact same idea for brown. You can do the same work to do blue or green eyes. Can you generalize the results from the sample to a local college? We've talked about that. Maybe you can, maybe you can't. I would say maybe you can't. Okay. So what limitation would you include to make your prediction more accurate? You would just state that. If you think, yeah, the eye color could change from college to high school because you have various different reasons for that, then just state that as you make that assumption. Okay.